wouldn't be a virtual thing if I didn't have any muting issues or audio issues. Cool. Thank you all so much for hanging out here. We're gonna talk about TypeScript. We're gonna talk about performance. Let's. I'm gonna start off with something real quick. I do love TypeScript. I have a lot of love for TypeScript. It literally helped change my career because, I was able to at least get better understanding of the things I was writing and the code frameworks I was using, the libraries I was consuming. Without TypeScript, I don't think I would have had any of that knowledge available to me in editor. I was able to write better programs because of it. Everything changed once I picked up TypeScript and was able to uh, get up and running with it. And if you're not using TypeScript in your day to day, like no judgment, it is okay. You can just let us know. I'm not going to judge you, but you should really be checking out TypeScript for a lot of reasons. If you're working with frameworks, like I would assume most people are these days, TypeScript is, going to be an essential part of that. Maybe not for the framework of choice, but definitely for, kind of the third-party ecosystem that exists around your framework. For instance, we've just spent a lot of time talking about Angular. Angular is very unique in that it is so tightly coupled with TypeScript. But if we took React, for example, swap out React with any other framework, you're going to find out that there's a lot of open source repos out there that are all built for that particular framework. In this case, there's over 6 million repos on GitHub for React. And this covers everything from state management, UI libraries, CSS and JS, and other style solutions. Anything that you could think of is out there. And if they don't have types or aren't written in TypeScript or having some way providing that information, you're going to be lost because it's impossible to know everything. Even with all your fancy AIs that exist, the AIs need some kind of information to be able to build up that model. Types act as a way to provide that information to not only to the AIs, but to you as the developer. So that way you can actually know what that library is doing and what it accepts as parameters. However, this is the part that I want to be clear. TypeScript is so slow. If you have not noticed TypeScript performance issues, you just have not worked on a big enough project. Anyone in the enterprise, anyone doing something more than hello world will immediately notice how slow TypeScript can be. Let's talk about that. So it's kind of weird seeing my face inside of the slides and inside of the screen share. It's like Mike Inception. As I've stated, my name is Mike. I work at Nx. I do a lot of DevRel stuff. You can find me online basically everywhere as M. Hartington. I'm mostly on Blue Sky now, so just come hang out there. Ask some questions if you have any afterwards. Love the chat. But we're talking about TypeScript. TypeScript in this case is slow, and we want to know why. But first, we need to understand what we mean by slow, because slow is one of those things that everyone just throws around, but it can have different meaning based on the context. So in this case, I want to focus on two unique areas of speed and slowness. The first one we're going to look at is build speed. Build speed is literally just that. How long does it take for TypeScript to take some source files and generate something that is not source files, or just process them? Slow builds are literally a very, let's say they're a linear, it's a linear curve in the fact that the more stuff that you are throwing at TypeScript, the slower it is going to be. So let's take a look at a demo. And we're going to use this very extreme example because, well, I want to illustrate not just building locally, but building in a CI environment, because a CI environment in this case cannot be modified unless you run your own CI setup. Most of the time, we're just using something like GitHub Actions or Circle CI, and those resources are pretty much set in stone. So, what would happen if we were to just throw, I don't know, about 500 files at TypeScript? Um, that's a lot of files. I don't want to undersell how large that is. Let's go ahead and just run build, and we're just going to add time to the front of this to get a time output. So 500 files, all we're going to run is tsc/b, and we're going to check to see how long this will take. And this is the part that gets really, really nerve-wracking, is that it takes so long. Right now, even with everything running, like the live stream, this is far too long for me, and we're just going to let this go on for a second and see how well this does. Oh, it's so painfully slow. I'll skip ahead and we'll come back to see how long that took. But this is a large app. There's a lot of single files all over the place. It's a good illustration of just throughput and how fast can it process it. And there is an easy trick to fix these speed issues. Let's check to see if it's done yet. It's still going. There is an easy trick to solve this problem, and that's just to stop building large projects. It's kind of a troll answer, but I'm being very serious. If you're building large projects, you're going to see speed issues in your builds regardless. Build smaller things, and you're going to have a better time. And this is, kind of a shameless plug. Monorepos are perfect for this. Whether or not you use something like NX, you could use any other monorepo solution out there, and you're going to see that performance get better. So our build ended. We ran about 101 seconds for everything to complete. Let's check out what it would look like if we were inside of a very minimal monorepo. So we took the same code, and instead of shipping just a giant file that we're all going to process, we now have split this up into individual libraries. Each library has its own tsconfig, its own source directory, and some more files just to just the whole entire project in there. So let's go ahead and run this. And what I'm going to do is I have a special command in here. We're going to run npx, we're going to run time npx nx run many. This is just a way for nx to run multiple commands in parallel. It's like concurrently. We're just going to give it a flag of what command to run, and we're going to run the type check command. So this is just going to run the TypeScript compiler. And we're going to... The wonderful thing about NX is that it is so fast that sometimes you have to disable the cache. So let's run that again and disable the cache for it. Let's check out how this is working. Gonna give it a moment to just run. And we're gonna let it work, do its thing. Okay, so it's fine. It's not running any faster, I believe. Okay, I think I know what the issue is. This is not as good as it can be. The speed will eventually... The build will actually finish, actually complete eventually, but the speed here is not that big of an improvement. What happens? Well, to know why this isn't better, you gotta kind of have to know how TypeScript works. And so in our large single project that we did for demo 1, we were importing everything as basically just relative imports. TypeScript would just go ahead and follow that link, bring up the file, and build it into a dependency graph. In this very basic monorepo setup, we're actually using this prefix for a library, at acme lib-1. This is, a little bit misleading because this makes us think that we are importing things from node modules, or it's importing things from another module that TypeScript doesn't need to know about. Like, we're just pulling something from node, the node module directory. But this is actually a giant lie. This is actually using TypeScript's paths. And if you've never used paths before, it's basically a setting that you could add in your TypeScript tsconfig, where you can say, when you see this string on the left-hand side, in this case, acme lib1, swap it out for this path at build time. And if we look at the build, it's not getting any better. It's because paths actually don't do anything other than just rewrite the import statement. So this seems pretty obvious when you say it, but the number of folks who think that by just using paths they're going to be setting up a correct monorepo is very high. You should not be using paths for most cases when you're inside of a monorepo. And by the build still running, we can see that we are definitely not improving things. So how can we... So with paths, we're actually writing this, but TypeScript's compiling it down to this. So things aren't better. And that's because TypeScript is actually being asked to do two things here. Type check, but also resolve the file at build time. Paths just are basically rewriting your import statements, but not actually isolating things into smaller chunks, which is the whole point of a monorepo, but also the whole point of being able to speed up your builds. So this is where something like workspaces come into play. If you haven't heard of workspaces, it was super popular from the Lerna project, but it's not something that is supported in NPM, Yarn, PNPM, Bun. Basically a way for you to say, hey, node and node modules, they're going to be individual packages inside of these directories, and we're going to treat these as workspaces. So when we go ahead and run an npm install, at that install, we're actually going to go ahead and say, create a bunch of symlinks to every directory inside of that node module. Anything that has a package JSON, create a symlink and treat it as its own node module. So this actually has TypeScript import things from npm as if it's just any other node module, which is key here. So let's take a look at that. Hey, our build actually completed, and it only took 220 seconds. Not great. So here's that same project, but we're using workspaces instead of just using paths. So you can see we have a whole bunch of symlinks to individual packages. Let's go ahead and run a build. And it's going to be the same command as before. We can just say t type check. And again, Nx is too fast and caches things. So we're going to disable the cache for now, and we're going to try to run this. Now, one thing that we might instantly note is that we are getting a stream of individual outputs versus the other one, which was just waiting at this one build. This individual stream is important because now we can actually see we are compiling things separately from one another. Our build took 40 seconds in this massive repo, and you can see everything took a couple seconds, milliseconds even. Nothing seems to have been over 100 milliseconds, which is great. And so our project was able to build, incredibly fast. But that's only part of the solution here. We're using workspaces to solve resolution. But when you adopt workspaces, you also get another thing that you have to resolve. And that's, how do you tell your project about, how do you tell TypeScript about your types? And that's where project references come into play. Project references are a feature in TypeScript that I don't think many people are aware of, but they are essentially a way for you to tell TypeScript about various projects or various types that could exist in your workspace. It's been around since 3.0, so it's rather old in terms of TypeScript, but I think it's only started kicking off since we adopted it at Nx. So in our previous example, we used paths. They're still lies. They're terrible. Don't ever use them in a mono repo in this case. References look similar, but they behave very differently. The same way workspaces exist as a way to point to other packages that can be symlinked into node modules, references point to other directories with a tsconfig. So this reference to path, package, lib1 is just pointing to a directory where another tsconfig exists that is setting up the compiler options for that one project. So this makes it so much simpler to be able to take your projects, split them up, and share those types all around everything. All it does once that's set up is make sure that the types are available, and it makes things work as you expect. There's no amazing thing about it. It just works, which is great. In fact, let's take a look at this. This is an old function that we have nested. It's nested, it's re-exported. We're using, let's see, TypeScript and TS project references, so we can see all the references here in this workspace. Let's just try to go ahead and get a reference for this. I know that this is actually being referenced in multiple places. Let's just try this right now. And we can see that this is being pulled into 6 places, including the current file that we're actually in. What's funny is that if we were to say, try this in an old project, let's open that same package and try to run our references again. We're actually going to get a warning. You can see it inside of my editor. It says no LSP references found. Because this is using paths instead of references, TypeScript actually kind of gives up at some point trying to find more references here. By just using project references, we're able to actually tell TypeScript a better story about what our project looks like, and it's able to better understand our project. I say it's more correct. My boss Victor says it's not more correct; it's just correct, which is a really great way to think about it. So that's build speed. Use project references. Use workspaces, and profit. What about editor speed? Because that was something that we also needed to figure out. Well, editor speed is a little bit more different. It's not about the sheer scale of your project. Like, you could have 1 million different packages inside of your repo, or probably more likely 1,000 packages. Where editor speed comes into play is when you have a lot of different type information. We're going to call this tomfoolery. There's a better word to describe it, but I don't want to say it. So let's take a look at what I mean here. So this is just an app that we had that's using TRCP. Let's go ahead and just try to get IntelliSense to work. TRPC, cool. We'll hit the dot, try to wait for our editor to get some completions. Okay, it's taken a little bit. Not looking great. I don't know about you, but if I was working in this project and it was taking that long for my types to be resolved, I would not be happy. And the reason why is because this is generating over 100 different TRCP routes with deeply nested routes inside of them, creating a very complex type structure. Not in sheer, like, just in sheer size. This is like so many different routes. And we can see that looking at this routes. There's a lot in here. And if we looked at one of the files, we can see it's just building up a lot of nested types, which is terrible. This is not something you should be doing. Again, tomfoolery. You should not be doing something like that. You're not likely to face this, but if you have somebody who is using some libraries that create deeply nested type structures, you might run into this, where the TypeScript compiler actually starts to shake up when you try to evaluate a lot of types live inside of the editor. However, it's that live evaluation part that we can kind of solve and make the experience better. If you get TypeScript to do less, you can actually make it a lot faster, and that's where you can think about pre-building your libraries. So this is that same exact repo. If we go open up the trpc.tsx, the only thing that we did here is that we have a post install script that goes ahead and builds everything and generates a .dts file instead of having TypeScript trying to evaluate things live on the fly. And so by doing that, we're actually able to get our responses back from our from TypeScript itself, so that way it knows a little bit more about. So that way it can like give us the information faster without having to wait for the evaluation. Now, there is something that I do want to call out here, and that's TypeScript Go. TypeScript Go is their rewrite or port of TypeScript's compiler to Go, which offers a lot better performance, a lot more kind of reevaluation of how they've done things in the compiler. So meaning everything in this talk could change eventually. But I will say that stable release for TypeScript at this point is 5.8.3. The Go port is targeted for 7.0, and 5.0 came out in March of 2023. I'm just going to make a safe bet and assume that we have a while to go before we hit the TypeScript Go support. So while we're waiting, we can actually start to do things a little bit better. So TypeScript can be slow. It's a symptom of bigger issues. Build small isolated modules so that way TypeScript can compile them in isolation. Consider moving to a monorepo with project references. Nx is a great solution, but there are other options out there. So that way you can isolate those things and build them separately from one another. Avoid complex types if you can. Don't do any of that tomfoolery. It's not great. And if you need to, pre-build so that way TypeScript can do a little bit less work and it can give you information a lot faster. So I have all my slides up. I put up this little link if you want to just copy the URL or do a little capture of the QR code. There's a lot of resources in there, some blog posts, these slides themselves. Definitely check it out if you are curious about this or want to revisit some of these concepts. But that's all I have. Thank you so much, and I hope you enjoy the rest of your conference.
Hey, thanks a lot for those amazing tips. I also see that you're a Vim connoisseur, so that's also very nice. Shows how efficient you are. Two questions from the audience. One of them is, what's the simplest way to start using TypeScript with React? Where can we learn the basics?
So simplest way to start using TypeScript with React, I would honestly suggest looking at something like the Vite React starter project. You could also check out NX's starter repo with Vite and React, and we'll get you all set up, punch you on the happy path, so to speak, where all your problems are solved. And if you're just trying to learn TypeScript basics, check out Matthew. I think it's Matthew Popok's. No, Matthew
Matt
Pocock's.
Popok. Yeah.
His
Yeah.
YouTube channel goes over TypeScript in depth, but also covers the basics. That way you can get a better understanding of it.
Yeah, I also recommend. He has quite some free stuff too, so that's always welcome. And
Yes.
I also appreciate the fact that you try to put the effort into bringing people on the happy path, because that way you're not discouraged and you really still get to use the tool. That's quite important.
Sensible defaults. That's all we try to bring.
Yeah. Do we have any trade-offs or limitations of the approach you presented?
Yes. One of the trade-offs is with project references. The downside is that if you are doing is that sometimes you need to tell the project itself. You have the main TS config, which has all the references, but then in your project itself, if you're trying to import libraries, you also need to update that TS config to include references to that project itself. So there's this very nested kind of way of referencing. The TypeScript team's aware of it, and they're trying to resolve it. We have a tool inside of NX that anytime you import something will automatically update your project references if you're using VS Code with the NX console installed, the extension. And we'll also have a sync that will analyze not only the dependencies in your file, but it'll try to build out that connection. And because it's a monorepo, we know every package that's going to exist, and we can help you out in that case. It does require a little bit more tooling, but we think the trade-offs are worth it.
Yeah, I used it also. Yeah, console is quite friendly if you have any generators or something to use. That's quite nice. Okay, yeah, perfect for this roundup of all the ways of making it faster, because everybody is very excited for the Go rewrite, but it's not there yet. So in the meantime, we can definitely use some of those tips. Mike, thanks again.
Cool. Thank you so much.